Okay, good morning. Welcome to
Fun Math number 27.
Fun Math number 27. Okay, today we're going to do a practice problem that's very similar to one of the challenge problems out of Art of Problem Solving. It's number 3 book that you're going to have for your homework today. Okay? That's the board super well. Find the 6 smallest numbers that are multiples of 12 and 21 that are perfect squares and perfect cubes. Okay, so there's a reason this is a challenge problem, because it's a real challenge. So how are you going to start on this one, by the way?
Well, we can find some perfect squares and see if they're perfect cubes.
Okay, well, what's going to make a perfect square a perfect cube? That's a good question. What do you know about numbers that are squares?
They're always an even power. The power is always an even power.
What power is always an even power?
The power of the square is always an even power.
What power is always an even power in squares?
The prime factors.
Right. When you factor into primes, you get even powers. Okay? Prime powers are even or multiples of 2. Right? What do you know about cubes?
The prime powers are multiples of 3.
Prime powers are multiples of 3.
Well, from this, I can already see that for them to be perfect squares and perfect cubes, they need to be to the 6th, or multiple of 6 power.
Aha. Now we're talking. So to be a perfect square and a perfect cube, you have to be a perfect 6th power. Okay? So your prime powers have to be multiples of 6. Okay, so that's the first thing we noticed. Okay? So now we need prime powers that are multiples of 6. But now we need numbers that are multiples of 12 and multiples of 21. How are we going to figure that out?
Well, we can figure out the multiples of the LCM.
Okay?
The multiples of the LCM.
Alright, so we got to figure out the least common multiple of 12 and 21. Go ahead.
Well, 12 factored is 2 squared times 3. 21 is 3 times 7.
Okay, so what's the LCM?
The LCM is 2 squared times 3 times 7.
And what is that?
12
Write that down. 2 squared times 3 times 7. And what's...
It's 21 times 4, which is 84.
Okay, 84. Okay, so the LCM, and it's probably easier to look at it this way, 2 squared times 3 times 7 is 84. Okay, so now we need to find the 6 smallest numbers such that x to the 6th equals something times 2 squared times 3 times 7.
Well, except we need 6th powers here.
Oh, okay. So this is going to be b times what?
2 to the 6th times 3 to the 6th times 7 to the 6th.
Go ahead and write that.
2 to the 6th times 3 to the 6th times 7 to the 6th.
Okay, 2 to the 6th times 3 to the 6th times 7 to the 6th. Which is 84 to the 6th power.
Which is a big number.
Okay, now, I've asked you again and again and again to learn your 6th powers. So do you know what 84 to the 6th... You don't? What? How do you not know what 84... I mean, everybody knows what 84 to the 6th power is. I mean, for example, my phone here happens to know it, I think. Maybe not. Utilities, calculator, 84 times 84. 1, 2, sorry, 3, 4, 5, 6. Yeah, it's big. Okay, so let's just leave it as 84 to the 6th. So what is the first number that's a multiple of 12 and a multiple of 21 that is a perfect square and a perfect cube?
84 to the 6th times 1 to the 6th.
84 to the 6th times 1 to the 6th.
Which is 84 to the 6th.
Which is 84 to the 6th. What's the next one?
84 to the 6th times 2 to the 6th.
What's the next one?
84 to the 6th times 3 to the 6th.
Yeah?
And all the way up to 84 to the 6th times 6 to the 6th.
Yeah, there you go. Okay, high five. Now you got a homework problem that's almost exactly like this.
Do I have to write out the numbers?
Well, write them out like this, right? 2 to the 6 times 84 to the 6, and 3 to the 6 times 84 to the 6. Yeah, you don't have to multiply those out, because those numbers are a little tiny bit. I think they're bigger than 100.
Yeah.
Yeah. Okay. Good job. Good job on this one.